Hello and welcome to CherrySTEM. We are here again, and we are brought to you by listeners and patrons such as yourselves. So I suggest checking out patreon.com/cherry and supporting us because we're awesome. And all the posts about these shows and the references and the audio files are available publicly for everyone for free through the same Patreon. There it is, public posts. Check it out. Do all the things. If you do want to support us, I suggest going to the uncommon loot tier. And yes, they are named after Borderlands weapon tiers. We have bandit, uncommon, rare, epic, legendary, Iridian. I missed lack of Iridian weapons. But yeah, check out uncommon loot tier. You get to hang out with us afterwards in the Patreon after show and feel good about supporting more of these shows. Hooray. So yeah, patreon.com/cherry. All right, I'm joined by my lovely co-host, Richard Rawl.
Oh, thank you.
And we have another new seed for you all today. It is more along the lines of things that make us go. It's more along the lines of like quantum physics type things. Because we do have some news that just came out in the past 2 weeks about sort of the future of physics. And then that by itself wouldn't be enough to necessarily be just a news seed show. So I added some other things that are sort of along those lines. Like there's a recent, we briefly discussed it in private. There's a recent Einstein planetary observation, and there's some we've also discussed this a couple of weeks ago privately, the quantum noise experiment that was accidentally detected and proven. So just like some quantum,
I don't know what you're talking about there.
You do, it's fine. It's fine. We can talk about it again, obviously, for our own and other people's refreshers.
All right.
Yeah, so I was thinking maybe we could like start with some quantum-ish things.
Quantum-ish.
Because I still had a few of those.
It's the smallest possible ish.
Yes. Exactly. And then move on to the bigger-ish, which is all the stuff that is now coming out that we recently found that is really cool. So, first of all, somebody published something somewhere.
Oh yeah, that's true. Yeah, you can.
All right, so and because you're talking about quantum steampunk, so we're gonna start with like some space Einstein-ish things, and then do
Super
quantum-ish
scientific
things. And yes, indeed. Oh, I see.
I love how we started this podcast like so formal, and now it's just so
devolved,
just crazy informal.
Because that's how we roll.
Because that is how we roll.
Cool. So let's talk about this thing real quick. It's just I'm just wondering how to get this structured, because we could talk about quantum stuff, then this proves Einstein right, but then talk about new physics, or start with like the lowest, most recent first, and then go from there. Maybe we could try that. So this was reported by CNN, which is just odd, but and the actual paper though was published in Astronomy and Astrophysics. I will read it. You don't need to.
Okay, no, go ahead. That's easy for me to read along.
And you can also read along on the YouTube video.
Wow. Okay.
That we're making right now. So the actual paper is right here in Astronomy and Physics. No, yeah, Astronomy and Astrophysics. Well, April 2020. Detection of the Schwarzschild. Oh, it's a black child. Detection of the Schwarzschild precession in the orbit of the star S2 near the galactic center, massive black hole. So that seems boring with a lot of writers. But what it means, according to CNN. So I'm distracted by this enlarged prostate urologist ad. CNN, very classy, good job. says, for the first time, astronomers have observed a star orbiting the supermassive black hole in the center of our Milky Way galaxy, and the star is dancing to the predicted tune of Albert Einstein's general theory of relativity. So essentially, it's just talking about how it's like general theory is. Right.
Yeah. Okay. So I'd like to say first off that they love to talk about anything that theoretically, supposedly, might kind of prove
because it's shaped like a rosette.
General relativity, right? Yet they don't talk about how we have 95% of the universe that we can't find, and is an undetectable magical fairy dust because of general theory of relativity.
But they may not know that.
So
it
that's just just a little offset of that, the parade of them. Everything that they find anywhere in the universe is somehow is related directly to general relativity.
Well, here's what they're saying: it's the rosette pattern here, like the fact that that's the way it's perception. The way it's dancing is to the tune of what Einstein general theory predicted, but he had general and special, and it's just I don't know, the whole thing's confusing.
Well, it's not just that they're taking one star's precession and
ignoring all the ways in which it's wrong about.
They're ignoring all exactly. There's a million different things that are wrong about general relativity, but they're focusing on this one specific thing. And here's the thing.
So on that note,
right? I'm not saying that. It's such a fine line, and that's the problem in discussing this, because there is a very fine line between what is right about general relativity and what may possibly be completely just way the fuck off. And understanding that general relativity descends from a great deal of prior art is what I have to always focus on. General relativity, it is not something that popped up because of just special relativity, by the way. It is not something that just came out of nowhere. And had Einstein never published special relativity, had Einstein been killed before 1905 and nobody ever heard his name, we would still have general relativity, because special relativity would have been developed by Lorentz and Poincaré, and then from there Hilbert and me would have developed general relativity.
Right. Sadly, it's not so. He's not so irreplaceable due to his plagiarism and other things.
But you don't even want to talk about it because it's not necessarily purposeful, not necessarily plagiarism.
But my point is, it wasn't unique work. Is that so? You could remove Einstein from you can apply Occam's razor,
right,
and remove Einstein from the history, and it wouldn't really have made a difference in terms of the speed or.
Right, even the timing of it might not have been. I mean, here's the thing. Actually, his fame, not just him, but his fame.
Given the unique circumstances,
did change the timing
of the history,
and so it may have actually may have taken longer, or it may have been a shorter path to it. There's no way of telling. It could have gone either way. But the point is that general relativity would have been developed. Special relativity would have been developed without Einstein. There were other people who were extremely close, coming to the same conclusions, and in some cases beforehand.
But it was very interesting that in terms of talking about the history of science, this one in particular, where the circumstances were just perfect historically to elevate Einstein to be a
so I'm not saying that
spearhead the movement.
Right. So I'm not saying that there is and it's not entirely general relativity's fault that there is so where dark matter comes from is this observation that galactic rotation rates are different than expected, and that's different than Newtonian predictions as well. So Newtonian gravity is also partially responsible for this whole huge. When I talk about the 95% of reality is undetectable fairy dust. That's because it's not just general relativity's fault, and so there is a little bit of getting to the details that I guess I should talk about there. But so anyway, so there is obviously, I believe there is hard, good science present here, but everybody's talking about the positive part of it, and so of course I want to bring up the negative. I want to try to bring up this, it's not as perfect, and there's a hero worship around it. There's a automatically attributing everything to general relativity, and a complete lack of focus upon the problems. And so this is part of an overarching problem with physics itself, where everything is a self-congratulatory parade for every little thing that might kind of fit. There's just so much confirmation bias that it completely locks physics into the inability to progress. And a lot of it is this feedback loop between people hearing all this good press and then people funding stuff that has to do with fitting within the orthodoxy, and then fitting within the orthodoxy, means that people, whenever in the press, will always want to have that narrative. So you have this feedback loop that is keeping science from progressing. So yes, when I talk about there being problems, the problems are subtle. There's very fine divisions, and sometimes I don't focus as much on the fine divisions because it's just it makes the message to when you need to point out to people that there are problems, you cannot go into the detail of those very fine problems. And so that's kind of the problem of communication, is that there's a conciseness that you need to say, no, there's something wrong here, no, they're not paying attention to important things. So
it's funny you should.
And I haven't even directly looked into this, but the thing is, a lot of times whenever they're getting into like the precession here, we've been studying stars going around black holes for huge periods of time, and you don't necessarily that this one is supposedly precessing according to general relativity. That says to me, why haven't they pointed this out before? Like I said, I've not read this article.
Let's do that.
Okay, well, go ahead. I'm sure they're going to talk about that one star.
Right, but so what was your point about that?
My point is that why, when we've been watching stars circling black holes for decades,
right? Why is this
this the first one, and why is it this one? Why have we not noticed this precession before? And
this was at the center of the Milky Way galaxy. Woo.
Yes.
So yeah, I see your point. If it's like such a ubiquitous law, why is it not more found?
Yeah, and there are things that there's so much confirmation bias. It goes all the way back to general relativity's first major thing that made it popular, which was the sun. Was it the eclipse? That there was this whole expedition to take pictures of this eclipse, and it was heralded around the world as perfectly proving Einstein's theory right, and the data was terrible. It didn't prove a damn thing. Anyway, go ahead.
Yes, that seems to be not applicable to the specific situation.
Oh, it is. You herald the data, and then it doesn't. It can be within a margin of error that's gigantic, and just because people have confirmation bias, they'll take the clickbait news as as the proof, and that's basically what keeps happening over and over. Go ahead. I know you're wanting to continue forward on this. I'm sorry.
Well, just a million years ago, you mentioned Newton.
Yes.
So,
okay.
If we could circle back to that. One of the things they're mentioning here in this article is, so I mean, that's still a valid point you bring up about why don't we see this more often. But to sort of juxtapose, I guess, Newton, gravity, and general theory of relativity, that's a thing that not everyone might be familiar with. Maybe myself included. I just, because there's a lot of things happening there. But they're saying here that Newton's theory of gravity suggests the orbit would look like an ellipse, but it doesn't. The rosette shape, however, holds up Einstein's theory of relativity. I don't know how or why, but that's what they're saying.
That sounds like bad science reporting.
There's a link. Quote, Einstein's general relativity predicts that bound orbits of one object around another are not closed, as in Newtonian gravity, but process forwards in the plane of motion, said Reinhard Genzel. He's the director of Max Planck Institute in Germany. And Genzel also led the program that demonstrated this result. The initiative strove for increasing the precision of measurements was over a 30-year whatever. So yeah, it's the
elliptical nature of orbits is they confuse something there. The science reporter confused something. It just has to do with the precession.
Well, I do have the paper here.
Like the anomalous precession, or the precessionary period of Mercury was a big issue during the time that general relativity was being developed, and it was something that Einstein was constantly talking with his other his colleagues about how to fit this into a theory, and so it was a big part of developing general relativity to fit precessionary effects into the theory.
And there's the actual abstract, and
And the funny thing is, just 15 years ago, by the way, it was if you talked about. There was this one quote where somebody said Einstein jiggered the numbers. This is the quote, and meaning that he moved the numbers around to fit the procession, and that is simply factual history that you can look up very easily. That he was constantly talking with all his colleagues. So the way that it was stated, people have fought against it. Like I remember 15 years ago, they were constantly, oh, that's a lie. That's he it was just pure from genius and more hero worship stuff.
Right.
And when the truth of the matter is, you can look it up and it's like no, anybody it would be absurd for him to not attempt to take all of the data that is available when you're trying to create some new version of gravity. That is, to not use all the data available and then to publish where it does not fit the available data in hopes that you have actually published something that is incrementally more useful would be absurd. So calling it jiggering the numbers is kind of inflammatory unnecessarily, and people then reacted to it. But the point is it didn't need to be inflammatory, and their reactions are just wrong hero worship. So both of them were wrong.
Right.
Because yes, of course he constantly was working with people on fitting the data into his model during the development, and that is a natural part of science. So there's just nothing to see here, kind of. It's
nothing burger.
Right. But there's 15 years ago though, you dared say that he jiggered the numbers, and that was. Or that somebody, because that was the typical repeated thing, and people would lose their minds.
I think it's just the word is very it's a very problematic sounding word.
It comes from, it's like it probably comes from some quote from the 1920s or something.
I know, it's just very difficult.
I don't remember exactly who used that quote, but that was the common one that you would run into everywhere in various groups of people discussing physics.
But it just is, it's kind of weird that they would, I do have the abstract for the paper. It's just like here now in February 2020, this is like what they're doing. Like, I don't know, it feels kind of weird and odd attempt to like back all the way up and be like, Newton was wrong about this one thing. And it's like, okay. Seems like we have more pressing issues to talk about in physics. Because like literally everybody keeps calling for...
understanding those small deviations like that is kind of like the stuff that we do with quantum physics. In other words, like blowing something up to huge sizes and seeing these very, very fine differences that are aggregated, that may be very small at like our level, the effect that causes precession versus Newtonian gravity, like within our solar system, navigation of all of our spacecraft, etc., is purely Newtonian. We do not use anything from general relativity. However, when you get to the billions of stars level, and then there is this very small effect that has to be explained, and so what is that effect? And there's actually. In our solar system alone, just Mercury's precession that did need to be explained because it had already deviated from Newton's more simplistic idea. So it's it is something that definitely has to be. I mean, it's with it being present here in our solar system, that by itself means it is something that is crucial to developing the theory further and understanding some finite details, and it will picking out little things like that will eventually lead to a better theory, I believe, and so that it is very important.
Cool. Do you want me to read the specifics of their abstract, or
that might be good? At least the abstract, yeah.
Yeah, that's all we have. Just to sort of like understand, because you said there might be some science communicator miscommunication.
Yeah, that's what it sounds like.
So there's a lot of authors, like just so many.
Of course.
So many authors.
It's consensus science. None of us is as dumb as all of us.
So they're using the system of gravity, which is developed in collaboration by the Max Planck Institute, which is where that guy was quoted from saying something or other. and a bunch of other things. So the star S2 orbiting the compact radio source SGRA asterisk is a precision probe. Oh, okay. It must be gravities because that's the little, the first little asterisk. So the star S2 orbiting the compact radio source is a precision probe of the gravitational field around the closest massive black hole. Candidate. Over the last 2.7 decades, we have monitored the star's radial velocity and motion on the sky, mainly with the Symphony and NACO adaptive optics instruments on the ESO VLT, and since 2017 with the 4-telescope interferometric beam combiner instrument Gravity. In this letter, we report the first detection of the general relativity Schwarzschild precession in S2's orbit. Owing to its highly elliptical orbit, wait, I thought they were saying it's not elliptical. S2's Schwarzschild precession is mainly a kink between the pre and post pericenter directions of motion equals plus or minus 1 year around pericenter passage relative to the corresponding Kepler orbit. Oh God, this is a lot. I don't know if I can continue. We're like 2 sentences in it, and
they're just describing
done.
precession. No, you can be done. They're just describing precession. But the thing is, there's things like the lens throwing effect that sometimes I'm curious if they properly consider these multiple what's it called? I found that sometimes they'll have these effects that's like there's this effect that we expect and there's this effect that we expect, and then they'll act like they're two different things when they may be simply the exact same one. So the lens flaring effect, why I bring it up is because it's called frame dragging, where basically there is a whirlpool around any gravitational body where the space itself is in motion. So of course this lends itself quite well to a fluid-like space, but and so there's been numerous tests of this whirlpool like effect that have been seen in around black holes. It's seen around, there's a variety of ways in which the lens flaring effect occurs, and so it seems to me, of course, that it would be directly related to this, but then I don't hear them talking about how frame dragging affects precession, because of course if there was frame dragging, it would certainly affect precession. Why don't they talk about it? I'm not exactly sure, and that's something I would have to do, a little more looking into it, because it just doesn't make sense. And sometimes I find that you would think that's like, oh, of course they'd think that out, that if there is a frame dragging effect, that of course anything orbiting through the space that is being dragged around will have its precession, be altered. Of course, they'd think that out. However, your of courses don't work out because of the level of specializations that these people sometimes have. They do not look at the crossover of various effects that you would think that there's just no way. There's no way they wouldn't consider it.
Think that.
No way.
They're professionals after all.
They're professionals. There's
Right.
no way they wouldn't consider that. And time again, I find they do not consider it. And so that's right off the top of my head. I'm like, how are they making sure to combine these two effects? Are they combining them? Are they looking at their overlap? Are they, and I'm guessing probably not. So because that's been my experience, is that unfortunately, if it's named something else, they don't think of it as the same thing. That's different.
Right.
They don't look at the overlap between them. So it's just something I'm curious about. But
well, they do mention actually the Mercury thing that we talked about earlier as well, in the CNN report on it. Well, I mean, they're also quoting this guy from the Max Planck Institute. This famous effect, first seen in the orbit of the planet Mercury around the Sun, was the first evidence in favor of general relativity, Gensel said. 100 years later, we have now detected the same effect in the motion of a star orbiting the compact radio source Sagittarius A in the center of the Milky Way. This observational breakthrough strengthens the evidence that Sagittarius A must be a supermassive black hole of 4 million times the mass of the Sun. Oh, I didn't realize they didn't. Well, they said it was a supermassive black hole. That's why it had candidate in the parentheses, because they don't know if it's actually a black hole.
That's
Seems
been
like.
like I think it's been like freaking 30 years that people have been talking about supermassive black holes in the center of galaxies.
Right,
and
but it says here
and we've got lots of evidence
this
of
observational breakthrough strengthens the evidence that Sagittarius A must be a supermassive black hole. And that's what the guy said from Max Planck. And then the next sentence from CNN is Sagittarius A is the supermassive black hole at the center of our galaxy. Bitch, he just said this might be. What?
There's different levels of,
I'm
of
so
certainty.
confused.
And so, like, some people will be extremely uncertain about something. Some others
I
will
guess
take
he's
it
doing science.
completely for
He's
granted.
doing science talk, where in science talk
In science
you're
talk,
never
you gotta
sure
be
of anything
nothing.
ever.
I'm not
Never.
sure of anything. Never.
Never.
I never said anything. You can't hold it against me.
No, like literally, you're forbidden to say words like "proven" and shit like.
Well,
I
yeah.
remember like when
Right.
we were going through
You
school.
can't make any assertion. But part of that,
Right.
no, part of that is just
And which
because
that makes
they don't
sense,
ever
but-
want to be seen as having been wrong about it.
But it makes sense when you're teaching.
It's not just because of the theory. It sounds like, oh, well, they're just trying to be scientific. No, a
yeah,
lot of
and
times
when
they're just
you're teaching
trying.
students,
They're just
that's
trying
nice.
to keep from getting having anyone say that they were ever wrong about anything.
But they don't have really any. We mean scientists, en masse. They don't seem to have much ability to have impact on much of anything unless like a president calls a cabinet and they test it. You know what I mean? Like, but it's usually like head of the FDA or the CDC or something random like that. It's never just like scientists.
So I'm going to claim that they often do not pay attention to just things that are just blatantly,
Right.
glaringly obvious that of course they would have considered. And I'll give an example of that. And one of them is that when we look out to the stars, we see that this whole reason why we have the idea of the universe expanding, etc., is because every body, every heavenly body, every star that we see out there is redshifted directly proportional to the distance it is from us. The further it is from us, the more it is redshifted in a very exact proportion.
Right.
So that of course makes it seem like we're the center of the universe. There's a whole lot of gymnastics around explaining that I don't entirely buy. That says that we're not the center of the universe.
Right.
But I could see how that might be true. That there is it's just like whenever it's kind of similar to whenever you look at the sun's rays, it looks as though the sun must be just above the roof of wherever, because the rays, when you're looking at them, look like they're at angles that are pointing to a place that is very close by. However, it's not.
I'm not sure what you mean.
It's some kind of, I guess it's an observation that you would have to have done if you've ever looked at sun's rays. They don't all come down in a straight line. Right? They come down and they're pointing up at the sun. Well, if the sun is 93 million miles away, why is it pointing to a place that's just right up in front of you? Because it's an optical illusion. And that's what I'm saying is that may be true. I still feel like there's something that I don't like about their explanation of the whole, being the center of the universe and the exact linear progression of the redshift. But regardless of that, because I don't want to get into all of that, because it's really a whole lot of loop-de-loops they do in their explanations of things that are a tremendous amount of hand-waving, and there's hand-waving that is accepted in the community, and then there's hand-waving that's not accepted in the community, and it's completely arbitrary based on whether or not it supports consensus. They'll swallow it whole no matter how ridiculous it is if it supports consensus, and no matter how well supported it is, if it does not support consensus, they'll call it hand-waving. But the point here is that there's something called Compton scattering. And Compton scattering is an effect.
Background cosmic radiation.
Right. It's an effect that where there is a very small effect in redshifting any light that passes through plasma, and we know that there is plasma all throughout space. However, talking about that as an alternative is just basically never done. I found like one paper attempting to refute it based on the idea that, well, if there was scattering, the angle of incidence of the particles would cause blurring, and because we use it in these in MRIs, etc. And well, of course, that's just that's easily refuted, because the fact is that any scattering that happens from that has a bad angle of incidence would never reach us. The light simply wouldn't get here. And so only the light that can get here, because it is scattered directly forward, is the only light that factually does reach us. But it does then give us an explanation for cosmic background radiation, which is light that is scattered from other places that does not progress directly in the angle of incidence that it initially started in, and it has scattered towards us from plasma. And that actually makes much more sense to then somehow there's some we are seeing the Big Bang still today.
Right.
So anyhow, that's just one example of ways in which there's just this obvious, of course you've considered Compton scatter, right? Lots of people have really dug into this, and you didn't just buy that there's this linear progression that makes us look like we're the center of the universe, where redshift is exactly proportional to the distance. Surely you didn't just buy into that carte blanche without looking at any alternatives. Yes, they did. And so there's just numerous times that you'll run into this in physics. So anyhow, go ahead.
I always found it fascinating how you can just have such certainty as to the exact time frame of when the universe was created. And
yes, at 0.382 picoseconds after the Big Bang, there was exactly this much cold dark matter.
I mean, this kind of certainty is the what jokes and good omens are made of about the religious people and their certainty of
exactly. Right after the baby Jesus was born, there was exactly
the universe was created exactly on a Sunday and
right. Oh yeah, that's right. At 9:45 p.m.
Exactly. Yeah. So let's see. They continue. So Sagittarius A is the supermassive black hole.
Yes.
At the center of our galaxy. It is 26,000 light years from the sun. Our solar system exists on the edge of one of the Milky Way's massive spiral arms. Dense stars can be found around the black hole. One of them, the star known as S2, in this observation passes the closest to the black hole within less than 20 billion kilometers. It's one of the closest stars to be found orbiting the black hole. And when it nears the black hole, the star is moving at 3% the speed of light. It takes 16 Earth years for the star to complete the orbit around the black hole. Another quote by the guy who led the analysis of the measurements at the Planck Institute. After following the star in its orbit for over 2.5 decades, our exquisite measurements robustly detected S2 Schwarzschild's precession in its path around Sagittarius A. I'm assuming the Schwarzschild's precession is the Rosetta Stone shape, or what the fuck is the Schwarzschild precession?
They're just talking about
instead of the ellipse.
Yeah, it is still an ellipse that goes around in a
pattern.
In a pattern, right? Now that's the confusion from the bad communicator. Right, so.
Orbits aren't usually perfect circles. Instead, objects move closer in or further away during rotation. S2's closest approach to the black hole changes each time, which helps create the Rosetta shape. And the theory of general relativity predicts how much that orbit changes. The theory also allowed them to understand more about the general area at the center of our galaxy, which is difficult for us to see from such a distance since it's clouded by gas and dust in our galaxy. So everything we know about it is the theory. Observations of the star over the period of 27 years have made that discovery possible. The same team, it's a nice longitudinal study. The same team also previously reported the way the star's light stretches as it approaches the black hole.
Yeah, it stretches out as it's going through the image of it anyway.
Our previous results have shown that the light emitted from the star experiences general relativity. Now we have shown that the star itself senses the effects of general relativity. What? Okay. Said the co-author of the study and researcher at Portugal Center for Astrophysics, Paulo Garcia. Future telescopes like the European Southern Observatory Extremely Large Telescope, that's its name, will allow for observations of fainter stars that move even closer to the black hole. If we are lucky, we might capture stars close enough that they actually feel the rotation, the spin of the black hole, said Andreas Eckart, study co-author and project lead scientist from Cologne University in Germany. That would again be a completely different level of testing relativity. Whoa. So that happened.
Yes, and just like all the reports that the clocks in the atomic clocks in planes. Well, the atomic clocks in planes that prove general relativity that people have talked about for 50 years after it happened. The level of deviation of the atomic clocks was greater than the difference in it. So the atomic clocks in planes, bullshit. The atomic clocks in the satellite says a GPS system wouldn't work without general relativity. Yes, it would. They changed the time over and over and over because the deviation of the atomic clocks is much higher than the error of the atomic clocks is actually higher than the effect that they adjust for, because there is a differential effect. There is both the motion, which makes them adjust the clock in one direction, and the distance in the gravity well, which makes them adjust the clock in the other direction. So it's smaller than special relativistic effects or general relativistic effects alone, because the two of them work against each other. So it is a super, super small effect that is smaller than the error of the clocks. And so they're constantly readjusting the clocks from
resyncing
from the ground. They're resyncing them every day, sometimes multiple times a day.
That's crazy.
And so it's complete bullshit that has been. You've seen. I could probably find 1,000 articles to talk about how at least 1,000, minimum of 1,000, that show that the GPS clocks prove that general relativity is correct. No, the GPS clocks in the satellites do not prove a fucking thing. And it's just I've just spent so many years watching them repeat the same lies that are based on just confirmation bias. They do absolutely no real work. There is zero skepticism in skeptic communities. Zero. I mean, it is like perfect. There's not even I don't have to use a 0.000. No, just perfectly zero.
Well, if you're accredited,
okay, that's hyperbole. But either way.
Well, if you get accredited, you get an auto pass by a skeptic community.
Right.
If you have the right credentials.
If you wear the right hat, automatically you're right. Just like for thousands of years, if you wear the right hat,
basically,
humans fucking love their hats.
They love their uniform.
It's so important. The uniform and hat there's nothing that has more to do with the truth or falsehood of a person, because that's what everything's based on.
Well, that plus group preselection.
Right. That's what it is. It's a symbol of group preselection, which is why if you wear the right hat and uniform, you are that thing, and therefore everything that you say has to do with that thing.
Explains Pope hats.
Yes.
They're very large.
Oh, that's because they're very, very true.
Yes.
The largeness of your hat and your truth. Well, actually, I think it's the pointiness of your hat. And
you see, both.
If you have 4 or 8 points with a square or octagon, oh my God, you are so right. The rightness of your rightness is. It can't be
infallible.
Questioned. It's infallible. The number, that's a lot. That's more than 1 point. I mean, the Pope, he only had just 1 big point. But I'm curious if is there a number to volume ratio of the points on the hats that determine how right you are?
We need to look at king hats.
King hats, they only had like 8. They only had, that's a lot of points. So the king hats did have a lot of points too. You have a good point there.
And they were very heavy.
We need to get you a pointy hat.
Yes, please. Okay, so from here, did you want to talk about the from the Einstein segue into the new theory that is being asked for, or should I mention some quantum stuff that I have, or bio-inspired voltage? I got some things.
What? Okay, well, I'll quickly talk about. Okay, so this month.
If you want to send me
starting
anything to
on
show
April Fool's Day
on the screen.
Huh? Oh. You can do you can Google Eric Weinstein.
Or you can send me a link.
I don't know what to do with it. I'll just talk about it.
Is there no like central gathering place that has a mission statement or like about me? Or...
EricWeinstein.org, I think. Maybe?
Yes, crowns. That's what we mean by king hats.
Right.
Those
king hats.
Crowns.
It's another hat.
Yeah, it's just a gold hat.
Yes, it's the headwear. Okay.
The status.
I like calling it a hat because it's funny, and I like making fun of how stupid humans are.
But no, I legitimately forgot the word for a minute.
Oh, really?
No, I straight out did. No, I do appreciate that. I was like, yes, that one. Crown.
Oh, I thought you were just going with the fact that it's all about the hat.
No, that's
the
all
hat
I could
that you
think
wear
of.
is so goddamn important to humans, and their estimation of truth is so directly fucking linked to your hat.
So directly linked. That's the only word I could think of.
Well, I mean, there's okay, it's also uniform because they showed with the whole what's it called the white lab coat effect and the changes to people's heart rate. And
but I mean, ultimately,
so many different things like that.
Ultimately, at the end of the day, it's all about authority symbols.
Yes, exactly.
Because uniforms are authority symbols.
Right.
And status symbols.
But it's funnier.
And a status symbol
That's too scientific. It's funnier that it's just hats.
Yes. And a status symbol is an authority symbol as well. You were sending me a thing?
Okay. EricWeinstein.com. Check it out. That's it. Or maybe it's not work.
Send it to me.
Yes.
Yeah.
No! You can fucking type it in, asshole. All right.
My keyboard is clacky and loud.
Too bad.
Oh.
All
right.
So starting April 1st.
That was like a month ago.
Eric Weinstein is...
no relation.
Huh?
No relation.
Weinstein, not Einstein.
No, I know, but no relation to the Me Too Weinstein.
Oh, that Weinstein. No relation.
No relation.
I forget.
I just know a lot of our
viewers.
viewers.
That guy even existed.
Oh, not a lot of the partisan viewers that.
Oh, who cares?
How?
All right. So anyway, Eric Weinstein. He actually is the guy who coined
Pronounced differently.
the phrase the intellectual dark web. And he was kind of joking at the time, but it caught on. Anyway, Eric Weinstein is he's a very unique guy, and I end up listening to a lot of his work just recently. But anyway, let's start with the actual thing that happened. So April 1st, he's like, well, nobody wants an April Fool's joke because of how things are going with the whole Rona. And so what would be something that's kind of like a that has that air of absurdity but is actually serious and might be valuable and useful and stuff like that. So that's the day he chose to pick, announcing something that he has kind of been holding in reserve for many years. He says specifically because he was worried about the effects it might have on mankind, and but then he just found that in this theater of the absurd, where we don't have enough masks and ventilators and things like that, with the way the country is going, because he was afraid that maybe if we have this huge advance in physics, then you give this destructive power to individuals. Possibly that's one of the worst case scenario that could end up happening, and so it's one of the reasons why he hadn't really even come out with this before. But he released this lecture that he had done at Harvard, I think, and so April 1st he came out with basically his explanation that is kind of rooted in an older observation that was called Hopf fibration, and that is fibration, like fibers, and it is and so that's kind of the central core of his thesis, I suppose. I haven't explored it in a great deal of detail, but it kind of matches with this recent, in the past 15-ish years, there's been a 15 to 20 years, there's been a resurgence of quaternions over matrix calculations because of the way that it works out in computer graphics. So people in computer graphics basically use this methodology, this mathematical method for doing transformation. Like, it was originally developed by Hamilton, and lots of people, they even called it evil back in that day. I think Kelvin called it a sort of evil, and so there were people who were against it, people who were for it, and and so it's just this interesting history that's neat. But so what it comes down to is the idea that spinners are kind of yes. That spinners are at the heart of some of the most important aspects of the geometry of space-time, and basically this is why this is so interesting to me. Even though he hasn't said a word about this, it is very related to fluid dynamics. And basically, like, if you look at the way that quaternions actually work out in especially in like 4 dimensions, there's the relationship to what are you looking at there? What is that? Is that
that's an article about vibration? Yep.
Yes. Oh, okay. Yeah, that's cool.
Hopf and topology.
Right. So topology
the vibration continued.
Okay, to put it in the simplest possible terms.
Hopf and homotopy.
One of the interesting things...
Oh, that's very sexual.
One of the most interesting things about this viewpoint is that whenever you're talking about a ring vortex, so the movement of a donut, a torus, which they're showing a lot of them here, which is a type of, that is part of topology, that is a, what do they call it other than torus? There's, what's another word for it? A manifold. And so there's this interesting aspect of manifolds. All these are part of general relativity. All these things are present in general relativity. So it's just another way of looking at the same thing. It's another way of conceiving of what's going on in space-time as rotational. In other words, local rotation. And then some of the things that you have to think about during rotation is if it's a rotation of something, like a fluid, then there's this kind of a gearing effect. So everything around it has to rotate kind of in lockstep. And so this leads to this behavior that you see in spinners, where there's a, look up spinner real quick so you can show the, and this will show you, this is a quick way of seeing why it is that spinners are important to rotation in a fluid.
Yeah,
and so it's 3D. Just spinner. Just Google spinner. SPINOR. Spinner. Spin or. There you go. Now go to the wiki page. Or that one. Or just go to the wiki right there. Either way. You got this. I believe in you. Scroll down. And click on that belt. That one. Yes. Click on that. Click on it. Make it big. Okay, so this is basically a representation of a spinner, which is, you can see that the belts never get tangled and they don't actually necessarily rotate. So it's rotation in a 3D space that is interlocked with the space around it. And there's this sort of figure-8 motion that is necessary for it, and it has to turn 720 degrees to return to its origin. So all of this is very, I won't get into how there's, interesting geometric parts to this, but so all of these are kind of related to Eric Weinstein's view of things, which of course is kind of exciting to me because it is very related to a fluid dynamical view of space-time. And even though he hasn't said that, like I said, he's not said any part of that. So that's cool. And that's something that I did not know when I found out Stephen Wolfram came out on like the 13th or so, something like that. I forget what day it was that he announced his own bid for the revolution of physics. And now, by the way, Eric Weinstein, he is a controversial figure. He's kind of part of that group of controversial science people who, he's associated with Harvard, but he's kind of an outcast in other ways. And so there's this group of people like, who's the other guy that he did his paper, but he's kind of controversial. He's a psychologist.
Oh, Peterson?
Yeah, Jordan Peterson. And then there's a neuroscientist who's also very controversial. Sam Harris. Yeah. So Sam Harris, Jordan Peterson, and Eric Weinstein, they're all kind of part of this group of bad boys that are
bad boys of science.
They really are. They're the bad boys of science.
No, you're the baddest of boys of science.
Yeah, I'm the baddest boy. They can't even talk about me. I'm too bad.
No, you do porn, it's not
right. Exactly, not allowed. Actually, Weinstein interviewed a porn star, so he's at least not. He should interview so shitty. You. All right. So he doesn't have the shitty attitude about trying to stay away from anything icky.
Which is odd for a manager of PayPal, but whatever. Well, yes. Okay, not PayPal, but Thiel's still though.
Yeah, Peter Thiel's stuff, right? So Eric Weinstein came out with his thing. I didn't even know about it until I just recently did kind of a deep dive on it. However, then Wolfram comes out, and I start watching. So he's got his own bid. He says, I'm going to announce it next week. He kind of makes a big deal that kind of spooks me because I find out about it through somebody publishing a paper at Cambridge who is associated with somebody I talk to on a regular basis who is a scientist and who has read my work. And that paper is a development of a fluid dynamics based version of, Kelvin's vortex atoms. It is an extension based on gauge theory, which is also very much part of Weinstein stuff as well. So all of these, they're all kind of coming, they're all circling around what I've been calling the neoclassical revolution. The revolution is now. The revolution is happening because of these mavericks, these bad boys. They are all saying, we're going to just do it. Fuck you. Fuck the system. We're doing it anyway. And so Wolfram is not so much of a bad boy as much as he is seen as a bit eccentric. He's also a CEO, and who is well known for his contributions to physics, and the way that what he's doing. So his announcement. So he talks about, in one of his announcements, he talks about how the ether and how it's a necessity. He talks about ADS CFT correspondence, which in kind of in relationship to this ether, which is, that was something I'd just been posting on in a group of scientists,
right.
And so I'm like, oh fuck, they're gonna, and this is something I've been working on for years. I've got a paper out there that I've shared like over a year ago, and I've kind of been waiting for a publication that I know that there was John Bush at MIT's doing the quantum hydrodynamic analogs, and he was about to come out with a big paper, last year, and I've kind of been waiting for him to before I do an updated version of a paper that I was going to publish. And then I hear that this coming, I'm like, oh fuck, they're totally, you're gonna beat me to the punch and not say a word about my existence. Because the what I'm doing is the high level version of everything, putting things together from a high level, saying this is what all of this shit means. Here is a way to tie all of it together so that you can conceive of it in terms that make sense, that go all the way back to physics history, and how we can do this revolution as a revolution of interpretation, because you cannot revolutionize the physics that we have now in the way that they're attempting to revolutionize it, because there are extremely narrow constraints for what you can do, because we have this gigantic record of experiments. You can't deviate from experiments very far unless you're just using interpretation and interpretation of what those experiments mean. And so my whole perspective has been to travel back 200 years in physics history and loosen things up in interpretation, so that by the time you reach modern day physics understanding, you have the wiggle room required to actually view all of these things, all these different kinds of rotations, all this topology. I mean, there is this rotational aspect of space-time that is occurring in general relativity. Once you get down to how, it's just the math is so far abstracted that it's hard to understand that there's a rotational aspect to it, but it's there in general relativity as well. And so trying to pull all that together into one big theory where we can go down and then investigate once again from this entirely different perspective and say, okay, how can we put these together from a new perspective? That's what I've been doing. And so this guy at Cambridge comes out with a paper doing exactly what I've been asking to do, the detailed part of it. That's the only people who ever get any recognition. And the funny thing is, he too, I found out, is a controversial figure somehow. He recently got some sort of, because they accused him of sharing information about people who were part of a group or something like that.
Like doxing or something?
But it was like
trumped up charges.
But he says he didn't, and basically he got some sort of disciplinary action just recently. And he claims it's just there because of the fact that he has a different view of physics, that he's being attacked.
Singled out,
and right? I totally fucking believe him. I totally believe he's not being part of the group and not getting with the program, so they're attacking him.
Look, they did that with Assange and others. When you're an undesirable, they try to use the law pretext or some sort of technicality of the rule violation to get the group to oust you.
Like that's one of the things that Eric Weinstein was talking about, that what's his name? Our boy, who's the guy who basically he was threatened with 30 years in prison for something he didn't even do, which had to do with he was downloading papers.
Isn't that about Aaron Schwartz?
Aaron Schwartz, yes. So Eric Weinstein was actually talking about Aaron Schwartz and how it's like, there's the most brilliant people are the ones that are kind of the bad boys, and that used to be something that people actually recognized and allowed, and now it is no longer allowed in the slightest. And so you end up having all those people who could actually make big contributions to science being pushed out to the edges or pushed completely out. And Weinstein's just barely made it himself. Actually, upon listening to a couple of podcasts by him, I was blown away how much I agree with Weinstein on most philosophical things. He calls for straight up like violent revolution, though, and I'm like, whoa, chill, dude. But hold on just a second. But he has a very revolutionary mindset, and I agree with him in a wide array of things. I was really blown away by that, but how much we agree with.
Yeah, that doesn't usually happen.
Yeah, I know. I was like, holy shit. But anyway, so going back to the most recent news with instead of Weinstein, the middle of the month was Wolfram. and so what Wolfram actually came out with, however, even though he showed that he knew about these things having to do with backing up just a second, I mentioned this paper where a guy is talking about a new version of gauge theory with Kelvin's vortex atoms at Cambridge, and and it was related to a person who I've been talking to in group about my theory, right. And that's the bad boy who is getting censored right now. The bad boy. The way that came up is I found out that Kelvin's vortex atoms are part of a class of models that Wolfram has identified can fit modern experiment and can fit the modern modern physics. And so the methodology by which he does this is through this, like, I do not understand it very well. It was based on cellular automata when Wolfram came out with a new kind of physics, and the truth of the matter is it's just so radically different from what everybody is used to that it's its own thing. And people think that they have an intuition about it, and they just don't, is what Wolfram is constantly repeating. It's like you think you have an intuition about it, and you just simply don't. It is completely new. And I believe him because I have seen some really amazing things. And which, by the way, in the news, the guy who created the Game of Life, which is part of a cellular automata thing, he just recently died of COVID.
Oh no.
Yeah. But anyway, going back to so the cellular automata leads to this network and graph theory, I think is what it's called. Let's see, is it network or graph theory? Wolfram, I'm not sure what he calls it. But basically, it is a methodology that is that I don't understand well enough. But the thing is, I've seen some of the amazing things that Wolfram's been doing enough to believe in the person, and that's one of the things that people don't quite do enough of in the right way. They do it completely in the wrong way and never in the right way. And that is looking at what the person produces and the reliability of the things that they produce as an estimation of of the reliability of the next thing that they produce. And that's the thing with Wolfram, is I trust that what he's doing is actually doing what he says it is. And so while he talked about the ether and the ADS-CFT correspondence, which has to do with holographic principle, the universe as a hologram, which is not what it sounds like, it's something different. But when he talked about that, that worried me a bit. And then I found out that actually what he was announcing was just that he has a methodology by which to identify and constrain the search area, which basically that's the biggest problem when you're trying to find something and you don't know what you're looking for. You're just trying to find something. Constraining it from infinite, because how do you go and test?
Right.
How do you go and search? What direction do you go? How far in what direction do you go? Constraining your search pattern is one of the most crucial parts of intelligence. It's the difference between knowledge and understanding is our ability to constrain our search pattern. And so it actually is bias is a aspect of advanced intelligence. It's a necessity of advanced intelligence. And so
Don't let him hear you say that.
do what?
Don't let him hear you say that.
Well, there's a give and take, and if they just we just have to accept there's always a give and take for anything valuable, and so that's true of like mindsets. There's a give and take. It's true of politics. It's true of you name it. There's a give and take, and recognizing that that's always there instead of having this one-sided view of methodologies is something that I think should be like the sine qua non of our development as a species for the future. Understanding that aspect, that yin and yang aspect, is absolutely crucial to us moving forward at all whatsoever. But anyway, going back to the Wolfram's thing, so what he's done is made a system of constraining, a system of identifying how models play out and how that they are capable of fitting within a certain set of constraints. And so that is an extremely valuable way of doing things. And the funny thing is he hasn't gone and specifically talked about the fluid dynamics interpretation of physics. And it's just weird. It's weird. And I think it has to do with exactly what Eric Weinstein was talking about. The indications that I've been getting ever since I started talking about a fluid dynamics version of physics is that, and I've talked to people who are, at Berkeley and at Caltech and at, and at major institutions where they have specifically told me they're actually part of DoD programs and can't comment sometimes and things like that. I think one of the reasons why people do not talk about it is because it is so close to the truth that it is dangerous. And they're worried that they don't know what will happen when we advance. They don't know how much this may give power to individuals. And because, while I am all for empowering individuals, I don't want to train monkeys to use automatic weapons and hand them automatic weapons. I don't want to do that. You don't go out there and give chimps that. It would help them in a certain way, but it would also hurt them in a certain way. And the same thing is true as like Eric Weinstein said when he was talking about his hesitation to launch his theory, was that for like 30 years or something he's been thinking about this Hopf vibration, and the thing that he was saying is like, imagine if the Columbine shooter kid had access to nuclear weapons. It's the horror that could be visited if you make too much available too easily and too quickly. And this is something that I've been thinking a lot about for a long time, is how to very carefully not make things too plain and too simple and too direct. And there's certain geometric considerations that simplify this even further that I have not broached publicly at all. And matter of fact, I haven't there's research that I've been doing that I have not shared anywhere at all. And so so I kind of follow what he's talking about, and I think that may be why this has been people are quiet about it because they're worried, and I think that worry is not unfounded. But I think like Weinstein said, and like I've talked to numerous people, we are now at a fly or die point in history. We either get out of the nest and take off, or we crash and burn, and that requires huge advancements in physics. It requires energy availability changes. It requires fundamental revolution for us to be able to deal with the massive changes and massive failure points that have been created by technology. In other words, we have gotten to this halfway point that it's just like if you go out to a tribe and start giving them they've been living off the land, and you start giving them food and trade and things like that make them dependent upon civilization, they then have to advance beyond a certain point, or they're stuck being exploited. They're stuck having like one of the tribes that's given food, they're not used to not throwing away all the plastic containers properly. So they've fucked up the land around them by just throwing things on the ground, because that's what you do with natural
Natural,
products as you
right.
throw them on the ground. That is a right way of thinking and doing things for their previous context, but they have to adapt. And so they're in this kind of halfway zone where they're not properly adapted to the technology. And the same thing is true of us, where we've gained enough technology that the technology itself is beginning to reach a level of harm that we have to get through to the other side. So like you fully integrate that group into a technological society, and then it's no longer nearly as much of a problem. It's that halfway point that is extremely problematic and possibly deadly to their area, to their group, to things of that nature. And so humanity as a whole now has reached that deadly doorstep where we are too far into technology, too dependent upon it, too interconnected with each other, too much dependent upon distribution. We are at this point where we must progress or have a catastrophic failure. None of us wants the catastrophic failure, because that means a huge culling of mankind that is going to be completely random, and basically the only people that are really going to survive are people who are very tribal. In other words, we'll devolve. Because the evolutionary advantages and specializations towards civilization and technology are very different from living, in a tiny group in the woods and hunting. That's very, very different skill sets, and there are very, very different requirements in when you put a lot more resources towards development of your brain and its size and its requirements. There's different requirements of fats and of foods and of so many different interconnected things. So we're talking about literally either facing de-evolution and collapse of modern society, or we're facing having to go through a difficult period of revolution in the other direction that is dangerous, that could, just like the birth of a child can kill the mother and the child. It is a dangerous new step that I've been calling childhood's end. That's where we're at as a species. We're at childhood's end. And so that's kind of where Weinstein actually kind of recognized that as well. He posed it in very similar terms to what I've been saying for years now, and been expressing to this group of scientists this group of scientists that I'm talking about. I'm not going to name any names here, but they are very, very connected people, and so this kind of information has been something that has been being talked about in a lot of academic circles. This is not a new idea, but it is a decision point that a lot of people have been going, what is the decision to make here? Because there is a level of obfuscation that is valuable. There's a level, under certain circumstances. You don't want to give nuclear power to every, disturbed child. You don't want to do that. And so there's a level of obfuscation that has kind of been purposeful, habitual, part of the academic habit. That I've been breaking with, and that others are now starting to break with as well. They're going, well, now we need to communicate clearly. Now we need to get the job done, and that means no more bullshit. This means no more, circling around and leaving things ambiguous about certain important aspects of how to develop the theory and how to move forward, and so it seems as though there's kind of something happening now this month that may culminate in the actual what I've been, like I said, been calling the neoclassical revolution for some time now, and it is it may start happening in earnest now as of this month.
Wow.
Yeah.
Pretty big deal.
Yes, it is actually. We're talking about a revolution that will touch every aspect of mankind.
I'd say that
Human
classifies under a big deal.
Yes. We'll literally change human existence in a fundamental way.
But in what time scale?
In what time scale? In a 10-year time scale.
Well, that's
very, very short.
Well, we need it. So.
Yeah. If it happens fast, I mean that is a fast, should things go really fast, yeah, we're talking about fundamental change in just a 10-year time scale, which is a blip. So that is as fast as things have been progressing. that is a level of danger that we've kind of got to embrace, because in that danger, in that exploration, is the safety, because the bridge has burned down behind us. We can't go back to a lot of things that might otherwise have been safe, and so there's a like I said, there's the pathway is falling apart behind us, and now we've got a leap that we've got to make. And that leap, yeah, it's dangerous, but it's not as dangerous as standing still.
Well, what do you mean by leap, though? And who's going to make it?
All of mankind in a variety of ways. In other words, there's a leap toward revolution. Okay, so the other thing that they're constantly talking about amongst these academic groups is how do we make revolution within constraints. So I've already talked about this is revolution through interpretation. You can't throw away everything that science has developed. You can't throw away everything that physics has developed and create a revolution, because physics is right. I mean, it's valuable. It's right about so many things. It's so valuable in so many ways. You can't have a revolution that throws away all that value. You have to make sure that the revolution is within constraints. And so that's on a different scale and a different perspective. You have to look at, if we're going to have revolution for mankind, it needs to be within constraints. We need to not throw away everything that mankind's been doing. We need to not have this destructive type of revolution, but have a constructive type of revolution where it's transformative. It is a breaking out of the chrysalis. It is it's something that is transformative in a constructive fashion and instead of a destructive fashion. And it's so much easier to have revolution in a destructive fashion, but there are many, many people who understand that what we must do, what we must find is the way to have revolution within constraints, to have revolution that preserves the good of mankind, that preserves all our best lessons, that preserves the best parts of our governments and our systems and all of these things and all of our institutions. Find ways that preserves them, that clears out the muck, that clears out the things standing in the way, and allows something else entirely to take its place that is fundamentally different. So in other words, basically stripping the flesh and keeping the bones and building new flesh on those bones. And so being able to, but it's more intricate than that. I wish it were so simple. But it's, we're talking about some cells have to stay and some cells have to go. Some organs have to stay and some organs have to go. And so it's so much more complex than just that easy slicing the meat off the bone. It is and so that is one of the big things that is kind of going on in the background of academia right now, is people talking about that aspect of, revolutions probably is coming in a variety of ways, and how do we constrain it, control it, focus it, make it good instead of us blowing ourselves to bits. And so that's also kind of something I believe that it's going on, and I feel very positive about it because a lot of people understand that it must be done.
You think it's in safe hands?
I believe it's in that there are a lot of people who are recognizing, regardless of their previous political leanings, regardless of their previous ideologies, their religion, their, you name it, there's a single path that everyone is starting to converge on towards preserving the future of mankind. And there's kind of there's a way in which there is a common enemy that we have now. Mankind has a common enemy that is our extinction, or not necessarily extinction, but the destruction of modern civilization in a certain way, and or at least extreme disruption of modern civilization. It's kind of hard to say whether or not there could be anything that would utterly destroy modern civilization. There is that possibility, of course, because there's lots of things like what's going on with climate change and the quiet time that we've had with volcanic activity and the likelihood of large meteorite strikes that we've been finding are way more often than anyone ever thought just 20 years ago. There's a variety of things that could, but the point is that that's what this revolution is going to be about, where we may actually be able to survive all of those things. and survive, and not just survive but thrive right through all of those difficulties and overcome them because of a fundamental change in who we are and what we can do. So anyway, you had some other things though that you were.
I don't want to be teased about my perfect sci-fi future without it like happening, because there's been such a disappointment for
Yes,
humanity.
it really has. No, but
we're supposed to have
talking
Star
about
Trek, but we ended up with Idiocracy. This is not...
Yeah, no, that's the best quote ever. I'm using that forever now. We were supposed to have Star Trek, but we got Idiocracy. You're right. But no, we're gonna have Star Trek. I'm gonna start a Starfleet in San Francisco, just like Star Trek lore. We're gonna start Starfleet there, and
that's where Eric Weinstein does stuff.
Yeah. So we're gonna make sure that happens.
Yep. So I do have this like strange paper here. Introduction to Neoclassical Interpretation of Quantum Steampunk.
Okay.
What is all that about?
It looks like it's too extensive to get into here.
Yeah, it is 74-minute read.
Yeah.
That's what it says. 74-minute read.
I'm sure it is.
Cool. Speaking of quantum, though. So this thing. Australian engineers accidentally solved a 58-year-old quantum mystery. Quantum mystery solved.
Oh, sure. Sure they did.
Well, no, actually,
Okay.
they did.
Okay, go ahead.
So, 60 years ago, Nobel Prize-winning physicist Nicolas Blombergen predicted an exciting new phenomenon called nuclear electric resonance, but no one's been able to demonstrate it in action until now.
Whoa.
Actual evidence was discovered accidentally. So it's University of New South Wales in Australia, thanks to faulty equipment. The breakthrough gives scientists a new level of control over nuclei and could seriously speed up the development of quantum computers. Dun, dun, dun. And the actual paper is Coherent Electrical Control of a Single High-Speed Nucleus in Silicon.
Oh, neat. Yeah, there's a lot of shit going on in quantum computing now that quantum computing has nothing to do with uncertainty, has nothing to do with David Deutsch's original computing in multiple dimensions bullshit, which, sorry, David, nothing but love for you.
No.
Love you, but no. The multiple dimension crap is never was going to work because it's based on magic. And so the thing is, well, okay, it's not actually, it's in different realities. If it was just different dimensions, that would actually be okay, because different dimensions can be just different ways of slicing and comparing different parts of reality. That's totally real. The different universes, not real. So the thing is, yes, now that quantum computing is actually looking at things from a perspective of analog computation and analog to digital conversion, and switching back and forth between analog and digital at the quantum level. This is the quantum computing has finally become real, and this is actually, as of the Google quantum supremacy announcement, quantum computing became a real thing, when before it was just imaginary bullshit. And it's because the whole idea for quantum computing before that point was bullshit. Now it's real. Now it will work. Now it will actually do things. And so that's a very it's a big development. And yeah, what they're talking about there, with by controlling spin. There's anytime you're talking about being able to control the very fine things, very small aspects of physics, then you're talking about miniaturization, and therefore being able to create high speed computational devices at a very, very fine level. And so there's problems with, in other words, what we're talking about with wave computation, analog computation, and analog digital hybridization. There is a there's pretty amazing things you could do with just really large, like waves the scale that you can see with the naked eye. You can do sorts of things that they could be, and I believe that they should be spending a little more time doing investigation at that level, where they can see things, and then there's a lack of error level that they may be able to control and constrain a little bit better. But that all aside, with their all of the advancements recently have to do with things like using light as an analog computation methodology for quantum computing. There's a lot of different things that are happening that are part of this revolution that is occurring. It's occurring.
Quantum punk.
Yes, quantum steampunk. That's actually something that there's a couple of. It's called quantum steampunk. Somebody made an article about it, and there's an article
Quantum
in.
punk.
No, there's an article on. Did you stop it? You keep interrupting me. I can't think of the name of the place. Asshole.
Like it's my fault. You can't remember the name of the place.
Modern. Who is the people who came up with the alien shit?
Popular Mechanics.
Popular Mechanics. Thank you.
You're welcome.
God.
Can I
There's a
get back to
Popular
this
Mechanics article and a Scientific American article on quantum steampunk that just came out this month as well. And what? Go, you should bring that up.
Quantum punk.
No, it's quantum steampunk. No. I'm looking at you. No more bullshit, young lady.
Yes, sir. So the peoples who found this thing, they got some analogies for it. So yeah, they found it entirely due to faulty equipment, but so this whole thing they're talking about controlling spin and such. So the analogy that they use is that the problem with magnetic so basically what they do with these quantum computers is stimulate them magnetically for some reason, right?
Yes.
And the problem with magnetic option is that it requires powerful currents, big coils, and a substantial amount of space.
Well, that's not what they did. They did it with Josephson junctions.
Not only that, in some ways, it's a bit of a blunt instrument. If you want to control individual atomic nuclei for quantum computing, perhaps, or very small sensors, the nuclear magnetic resonance is a very good tool for the job. Performing magnetic resonance is like trying to move a particular ball on the billiard table by lifting and shaking the whole table. We'll move the intended ball, but also move all the others. The breakthrough of electric resonance, instead of magnetic, is like being handed an actual billiard stick to hit the ball exactly where you want it. And the discovery means that we now have a pathway to build quantum computers using single atom spins without the need for any oscillating magnetic field for their operation. So that's the breakthrough that they found accidentally. So they can use apparently electric stimulation instead of magnetic to do whatever the fuck spin is and however the fuck that is involved in quantum computing. I don't know. But
well, spin is actually related to those spinners we were just talking about earlier.
Oh, neat.
Yeah.
Now that scientists know how nuclear electric resonance can work, they can research new ways to apply it. What's more, it was discovered by accident. So what happened there was that it was during nuclear magnetic resonance experiment that the New South Wales researcher cracked the puzzle that was set by Blumbergen in '61, the Nobel Prize winner. He was like, you must be able to do this thing, and nobody's found it until now. And it was all down to a broken antenna. After some head scratching over unexpected results, the researchers realized the equipment was faulty and demonstrated nuclear electric resonance instead of magnetic. So yeah, that happened.
Yeah, it's funny. There was a recently, I think on the space station they have antennas that were designed by AI. That do a better job of creating certain signals and things like that. They're just all weird. Like, nobody knows why it works. They're just like shaped in weird ways and stuff.
Neat.
Yeah.
So speaking of bridging the gap between humans and robots.
Robot.
I have researchers unveil electronics that mimic the human brain in efficient learning. Or bio-inspired bi-voltage memristors. Sure. So that's the thing.
What is this? I have not seen this.
Yeah, this is new. So
And
only 10 years ago.
Can you roll it back up there? It says, okay.
Oh, which one?
Electronics that bio-voltage members that mimic the human brain in efficient learning. Ooh.
But that's the actual
Okay.
paper from Nature Communications.
All right.
Bio-inspired bi-voltage resistors.
Yeah, let's read the abstract and then let's read the communication, the science communication part of it.
Sure.
The article.
Memristive devices are promising candidates to emulate biological computing. However, the typical switching voltage in previously described devices are much higher than the amplitude in biological counterparts. Here we demonstrate a type of diffusive memristor fabricated from the protein nanowires harvested from the bacterium Geobacter sulfuridensis that functions at the biological voltage of 40 to 100 millivolts. Memristive function at biological voltages is possible because the protein nanowires catalyze metallization. Artificial neurons built from these memristors not only function at biological action potentials, for example 100 millivolts 1 millisecond, but also exhibit temporal integration close to that in biological neurons. The potential of using the memristors to directly process biosensing signals is also demonstrated.
God damn.
So they're
That's
making
like, oh, wow. Yeah. That's
they're making biological thinking neuron things.
yes. They're
Thinking,
they're
well, yeah.
making
They're making basic intelligence.
well, no, they're making
biotech.
well, they're making biotech neurons.
Right.
Yeah.
That's what I mean by
engineering
basic
neurons.
intelligence, and it's like at the
Well, yeah.
at the level of like
Building
the sea
blocks
slug that can, you know.
Well, no, that's not even at the
you
level
can
of the sea slug.
plug it in and it'll like the thing that we used to do in lab where like we isolate a piece of it and we like put electricity in it and look, it responded. You know,
Yes.
just like basic level of stuff. So let's read. Only 10 years ago, scientists working on what they hoped would open a new frontier of neuromorphic computing could only dream of a device using miniature tools called memristors that would operate like real brain synapses. But now, a team at the University of Massachusetts Amherst has discovered, while on their way to better understanding protein nanowires, how to use these biological electricity conducting filaments to make a neuromorphic memristor or memory transistor device. It runs extremely efficiently on very low power, as brains do, to carry signals between neurons. Details are in Nature Communications. Yeah, we read that. As first author Tayanda Fu, a PhD candidate in electronic and computers engineering, explains, one of the biggest hurdles to neuromorphic computing, and one that made it seem unreachable, is that most conventional computers operate at over 1 volt, while the brain sends signals called action potentials between neurons at around 80 millivolts and many times lower. Today, a decade after early experiments, memristor's voltage has been achieved in the range similar to the conventional computer, but getting below that seemed improbable. Yes. Fu reports that using protein nanowires developed at UMass Amherst from the bacterium Geobacter by microbiologist and co-author Derek Lovely, he has now conducted experiments where memristors have reached neurological voltages. These tests were carried out in the lab of electrical and computer engineering research and co-author Jun Yao. Yao says, this is the first time that a device can function at the same voltage level as the brain. People probably didn't even dare hope that we could create a device that is as power efficient as the biological counterpart in a brain. But now we have a realistic evidence of ultra-low powered computing capabilities. It's a concept breakthrough, and we think it's going to cause a lot of exploration in electronics that work in the biological voltage regime. Lovely points out that Geobacter's electrically conductive protein nanowires offer many advantages over expensive silicon nanowires, which require toxic chemicals and high energy processes to produce. Protein nanowires are also more stable in water or body fluids, an important feature for biomedical applications. For this work, the researchers shear nanowires off the bacteria, so only the conductive protein is used, he adds.
So this is what I've been talking about. This is cyberization. I've been talking about how biotech will eventually reach the level that all of our electronics will be biotech.
Right.
And so if we've ever considered that other civilizations, it's just so much better to go into biotech. Okay, things that can self-repair at the nano level is what you need. You can't keep making the way that we do things right now. Our whole methodology of making things is just not sustainable. If we go into biotech, which is where we're going to go with technology, well, eventually we'll grow everything. We just have to start understanding the multi-layered data aspects of DNA better to be able to use DNA to program. And that's kind of part of this whole revolution that's happening as well, is that this analog revolution is understanding the way in which things that look to be ambiguous actually a lot of times are simply multi-meaning. In other words, it's a carrying of additional data with a singular configuration of a data storage substrate. So in other words, like if you want to store multiple sets of data, and I always I make pictures. I mean, I make posts with this picture of Morgan Theomachia's alchemy, and it's basically this thing that looks like two dragons if you look at it one way, but it's a face if you look at it another way, and basically it's the exact same set of ink, let's say, that makes two sets of meaning. And so this idea that and the whole reason it can do that is because of the lack of precision and a little bit of conforming of the data. Both the face and the dragons, both of them have to conform to each other in a certain way to be able to achieve this and there is a lack of precision in both of them that allows this multi-layering of data. So there's this analog process that has never been part of our understanding of how to do processing before, where greater precision, and then the other aspect of this is, of course, the idea of greater precision leading to less useful data is not something that's been part of our understanding of reality before. And this is something I've been trying to spread around, and I've been successful in spreading a great deal over the past couple of years. And that is basically understanding this this aspect of holographic information storage and computation. And holography is at the heart of neural networks. And this is not something this is something I've been trying to promote the knowledge of everywhere, and very few people actually realize how much holography and holographic storage is part of it. So going back to that whole precision equals worse data is basically when you look at a hologram, it requires you what you're looking at is the convergence of light from all corners of the hologram that you're looking at. It converges on your eye, and that is what creates clarity. However, if I cut off a piece of that hologram, the whole image will be there, but it will be less clear because it lacks the clarification of the additional information. And so there is so as you get down closer and closer and closer to the film level of a hologram, of a real hologram, you get a less and less precise picture. You end up, because of the way the data has to add together and be kind of present at each part of the hologram, you are by zooming in, you can't see the forest for the trees. It's literally, you lose information by zooming in. And so our whole scientific methodology, our whole pedantic methodology of doing science has been about precision, has been about getting deeper and deeper and more digits of perfection, and we think that is ultimately good on its own. It's an ultimate good. And no, it is a trade-off. There's a trade-off between breadth and depth. There's a trade-off between the precision and the amount of data that can be stored and processed simultaneously. There is a linear aspect versus a simultaneous aspect, and we're beginning to understand through quantum computing, analog processing, and holography that the way in which we can accomplish advanced methods of computation, advanced methods of data storage, all of these things are reliant upon this trade-off, which basically is imperfection, which is the artistic mindset. Why do we have the artistic mindset? Why aren't we all very computer-like? Because the imprecision and those types of aspects of the human psyche that make us more powerful than shitty old AIs has to do with our capacity for imprecision. It is a component of the way in which our intellect works, and the way in which we create, and the way in which we understand. All of these things are tied together. I kind of went off on that tangent for a particular reason, but I've forgotten exactly what that particular reason was.
Well, let's see. The last thing I mentioned was
biotech. So the creation of biotech is an inevitable aspect of the way in which the future of technology would go, and so I think that any significantly advanced civilization would be using almost entirely biotech. And you know what this means? This is the interesting part of that if we were to find, okay, so if all technology can be duplicated by biotech, so you can create electromagnetic signals, so you could create things like we already have done things like making diodes with biotech. So it would not take much to make light emitting diodes, which means that we can send signals with light. We could do basically every bit of technology that we have today. We could eventually replicate with biotech, and maybe integrating small amounts of metals may be necessary for certain applications, but for the most part, the vast majority of it is going to be biotech because of its ability to self-repair. Because, in other words, when you're talking about 1,000 years in the future, what is our technology going to look like? It's going to be entirely biological. We'll be growing everything. Everything will be based on that. If we continue to progress and grow and advance. So, with that in mind, we will, of course, be in the future integrated with all of our technology. In other words, your phone will be something that you have in your head. You'll be cyberized. So your ability to interact with the internet, for instance, on your device will all be just these cordoned off areas of your brain that you'll have cordoned off for safety reasons, etc. But the point is, it'll be biological aspects, and eventually a species which has grown into its technology would have the ability to do magic. You could cut them open and not be able to find a single technological device, and they'd be made almost entirely out of technological devices.
So that would have to be like in vitro.
Well, yeah, they'd have to alter their DNA eventually. They'd have to, and basically, once they've gotten so advanced with biotech that they're making all of these biological devices, they will then be able to make, remote control and all of those things that have to do with interfacing with other types of technology, which will also be biological. So in other words, they're so
this is very.
It would be like a D&D druid. In other words, they'd be able to like summon creatures not out of nothing, but they'd be able to from elsewhere. They grow out of the ground. Things that would be basically technology that they could control with their mind.
Brings me back to Horizon Zero Dawn quite a bit. And this definitely seems interesting in terms of biotech and appealing for my Trinity character, but my medic. But my real life self worries about the fact that we do live in a theocracy, and I don't trust doctors.
No, the other part of that is once the technology gets beyond a certain level of advancement, then the people who use it, especially if it's widely distributed, you may begin to lose touch with the base technologies, and such that you only can advance it to by what's it called, superstition. You can only, so like for instance, right now there's 5 people who program in COBOL. Nobody knows how all these various systems that our government is relying upon even work. There's very, very few people. Okay, it's not 5, but it's so damn few. That. All the people who program in COBOL are like above 55 years old. They're it's a very, very small group of people for how much it is a necessity. And the thing is that is basically how quickly we forget things. And when it comes to like assembly, like how many people program an assembler, or how many there are these things that are actually at the basis of our technologies, and they're still at the core of how they were originally made. And so if you take that and advance us 100 years from now, how many people are going to remember some of the things that become extremely stable technologies that all we have to do is just replicate what we were doing before? So we're going through the motions, and so we can superstitiously, without understanding, operate all the technology which creates our technology, but therefore lose the basic ideas.
Isn't that what we're already doing with like Windows 10? Nobody knows how it works, and
to a certain extent, there's almost certainly various things at the very bottom level of how Windows works. When it comes to ways of addressing the hardware, even though the hardware has advanced, there's a lot of different things that probably could be updated. There's probably a lot of bugs that are still there. I know somebody that we know actually works on that at Apple, going deeper into the code than and trying to find those old bugs and clear them out. Try and find solutions to them, but a lot of times what happens is there is no solution actually other than complete redevelopment, and so the only thing you can do is find workarounds. Workarounds are fundamentally different from real solutions because they require a less direct method of achieving something, and because there's less direct methodology to it, it is less becomes more complex, and you basically create a level of vulnerability that is kind of hard to describe. But when it comes down to it, the point is, I was just saying that various civilizations could actually continue to advance through the development of technologies that they don't understand, and that's an interesting. I don't know. It's just an interesting aspect of what can happen with technology, how it can become where you can lose. How easy it is to lose technology, lose the fundamentals, and it gives us interesting perspectives on the past, interesting perspectives on other civilizations. Like, if they're we're looking out at the stars for technology like our own, when their technology may be radically different than ours, so radically different that we're not going to detect it with any of the methodologies that we've tried to detect it with. And so there's just a lot of different interesting things there, along with the whole idea that perhaps old civilizations need new civilizations to rediscover the fundamentals that they've forgotten. If they're and I'm kind of assuming that there are that there is a whole galactic community, or somewhere in this world, in this universe, there are advanced civilizations that do exist. Just assuming that because I do assume that. And their reliance upon new civilizations, that they may actually, there's a variety of ways in which they may require new births, new civilizations to be born as part of a way to revitalize their own group of civilizations, is a interesting view of our current position, our current sociological position, our current technological position, our current all the things that are happening in the world right now.
They're saying reliance on it. So.
Yes, reliance. In other words, you actually, humanity needs new children to be born. We need new people with new perspectives. We need.
I don't think it's so much about perspective as like bodies, because old ones die.
No, it's old minds die for the same reason that old bodies die. And what I mean by that is they become too rigid, too specialized, too incapable of
adapting,
adapting outside
so
of
a species would not survive without that,
right. So species would not and technology won't survive without new minds able to solve the new problems that are constantly occurring, because it has to do with adaptation. You need the new generalized first principles starting over to be able to achieve the next level of adaptation. That's a requirement. So it's something that is a requirement at different scales. So humanity needs new babies to properly adapt as a species. Humans, social systems need new human philosophies to adapt to our changing environment. New, technology needs new baby technologies. Civilizations need new baby civilizations. There's all of these, and so therefore there is this truth that is available at multiple scales, and and that kind of revolution and rebirth aspect that we find, and that's very common to our stories that we tell each other all throughout humanity's history. I think is just a retelling of something that is a basic truth about reality, I suppose.
Yeah, that's one of your favorite examples is the jellyfish, right?
Right.
As the antidote to the whole vampire. I don't want to live forever.
Yes.
And I mean, let's finish this and I have one more question. So they used. So Fu says that he and Yao had set out to put the purified nanowires through their faces. to see what they're capable of at different voltages. They experimented with a pulsing on and off pattern of positive negative charge sent through a tiny metal thread in a memristor, which created an electrical switch. They used a metal thread because protein nanowires facilitate metal reduction, changing metal ion reactivity and electron transfer properties. Lovely says this microbial ability is not surprising because wild bacteria nanowires breathe and chemically reduce metals to get their energy the way we breathe oxygen. That's cool. As the on-off pulse creates charges in the metal filaments, new branching and connections are created in the tiny device, which is 100 times smaller than the diameter of a human hair. Yao explains. It creates an effect similar to learning, new connections in a real brain. He adds, you can modulate the conductivity or the plasticity of the nanowire memristor synapse so it can emulate biological components for brain-inspired computing. Compared to a conventional computer, this device has a learning capability that is not software-based. Fu recalls in the first experiment we did, the nanowire performance was not satisfying, but it was enough for us to keep going. Over 2 years, he saw improvements until one fateful day when his and Yao's eyes were riveted by voltage measurements appearing on a computer screen. I remember the day when we saw this great performance. We watched the computer as current voltage sweep was being measured. It kept going down and down and down. We said to each other, wow, it's working. It was very surprising and very encouraging. Fu Yao, Lovely, and colleagues plan to follow up the discovery with more research on mechanisms and to, quote, fully explore the chemistry, biology, and electronics, end quote, of protein nanowires in memrisistors, Fu says, plus possible applications which might include a device to monitor heart rate, for example, Yao adds.
The speed at which we're advancing is so fast now that nobody really understands exactly how far we've advanced on a variety of scientific fronts. And so because of that, now it's more a matter of weaving those various threads that are kind of going off on their own into one cohesive revolution.
Yeah. This is true. Well, you know more about the revolution than I do. I mean, I know some, but as you know. So one thing I wanted to mention, since we're talking about cyberization and such, aside from the new Ghost in the Shell thing that's on Netflix.
Oh yes, Ghost in the Shell on Netflix. We're definitely about to check that out.
What about all of these? So you were talking about like groups that you're in, and I know you're not dropping names or anything, but
no, stay away from names.
There's the interesting relationship.
I've only mentioned names of people I don't really know personally who don't necessarily associate with me.
The interesting relationship between that group of people and transhumanism or lack thereof.
Oh, that is so weird.
Yeah,
yes.
I think that's an interesting thing
to
end
on. It is very strange. Or what in this podcast anyway, I don't think I've mentioned it. I know I've mentioned.
We've mentioned it as just
person.
like still like just a good thing to cap off, which is fascinating that
Okay, so amongst this group, the one thing that has been strange, it's been very difficult for me to understand actually, is that amongst this group of academics, people who do neuroscience research, these are people who do research in AI, in physics, and there was this strange shared distaste that I've detected, not just from them, but from a very large community of people.
And you were directly told, not just detected.
Yeah, well, I mean, I've detected it from them. I've been directly told, but the
detection was for a large group.
I've detected that they really hate transhumanism in a very visceral, like reactive way.
Like a knee jerk, what you mean? Or?
Yes, very knee jerk, very
like that is automatically bad. We'll not even think about it.
Right.
Okay, gotcha.
Yeah. Well, and it's because a lot of these people are researchers in consciousness as well, and so there is a.
Are they religious? No.
A lot of them are religious, so I suspect that it has to do with
soul thing.
Right, that they think that that machine equals not soul.
Right.
And that's a big part of my work, is to say that our idea of machinery is a bullshit concept, and that everything in this reality is a machine. Everything that exists is machinery, and being able to, so like for instance, so one of the individuals I talked to who, he's all about love and kindness, and very much that's like a huge part of who he is as a person, and in peace, and things like that. Yet when broaching the topic of giving artificial general intelligence the same rights as a human being, he was very much against it and said he wouldn't even want to visit a civilization that gave those kinds of rights to an AI. And that really blew me away. I was taken aback, because that's just so
counter to what you would think.
Yeah, it was counter to what I would think would be, because this person is very, right? Very empathetic, very like his whole mission is about his whole mission in life is about spreading love. And I mean, of course, it's also, he's a neuroscience researcher, but his mission is life is about peace and love and unity.
Right.
And for him to be that viscerally against AI that tells me that there's going to be that those predictions that you see in sci-fi of a war between AI because they're oppressed, and humans who are very much against any kind of cyberization, etc. That's like, wow, that is a dangerous possible future that worries me, because I was like, I'm just kind of blown away that somebody that I consider to be a very kind person would be so much against it. And so we had a very long conversation talking about how life can be conceived of as just machinery, and all the way down to the cellular level, there's all this cellular machinery, and so thinking of it as anything else, and I think there's this whole spark of life, and I think it is there is this general feeling amongst people who are of religious conviction, and I'm absolutely not against religious conviction at all whatsoever. I think it is compatible, and that's kind of been something that has been a big part of my personal goals, is to show a way in which, if you believe in God and you believe God created this universe, then you should be okay with the idea of whatever this universe is, whatever we find is exactly what God intended and what God made, and so therefore cannot be incongruent with your religious beliefs. And so this is basically, I did not know what this was called until Eric Weinstein it's called Iron Manning instead of straw manning.
Oh.
And that is you create an argument for someone that is stronger than their original proposition instead of weaker. And that is what I've been attempting to do, is to Iron Man the spiritual community's arguments for spirituality. And that's a big goal of mine, because there needs to be kind of a I believe in there is a value to religion, and there is a value regardless of any kind of considerations of truth, the truthfulness of it, or etc. There is certain values to religion, and there is also well, it's a delicate subject that is difficult to broach properly, but there are, I don't like, I will unambiguously say I do not like most organizations of religion. And I don't think that any one religion has a monopoly on the truth, for sure. I do not feel that that's true, and I do not believe that I believe that most organized religions probably have things horribly wrong. However, I don't think that that any of them are completely wrong.
Is it called steel manning or iron manning?
I don't know. Maybe it's steel manning. I just heard it the other day for the first time, so I could tell Iron Man, Steel Man. Maybe it's Steel Man. Because I think it's like it as opposed to straw manning. Steel manning sounds better. I like that better if that's what it is. Somebody, yeah, okay. So it's just the first time I ever heard it. So yeah, I think that there is a tremendous amount of value to providing that for the religious community, because it is a huge part of our heritage. It's a huge part of who we are. We so because I have to make this argument for people who are very much kind of against religion, and that's the other thing is I have to be able to make people, regardless of where you are, there needs to be one singular argument for accomplishing something of value, and being able to show that it is valuable to both groups is part of my overarching mission, is to say both of you need to see the value of this pursuit. Both of you need to see one way of seeing the universe that both of you agree and interpret differently. And that's kind of the what a huge part of my work has been. And so anyway, I'm not sure how I got on that subject, but that's I think that's kind of, we're good to go. I think we've hit all the fun points here. And
yep.
What was I even talking about?
Well, the transhumanism hate.
Yes, you wanted me to talk about the transhumanism thing.
Sure did.
Yes. So that's kind of the solution to the transhumanism thing, and the possible war between people who augment themselves, because eventually you have the question.
That's what we're talking about here.
Yeah, that's right. We were talking about the recently came out Ghost in the Shell, and so there'll be these people who are so highly cyberized that some people won't consider them humans anymore.
Right.
There'll be, there's all these different
human rights and
human rights versus cyberization rights, and
versus,
so there's a huge bundle of
fast and approaching AI rights.
Right. So there's all these different things that are going to be huge considerations for ethics of the future. That's why this pursuit of finding a conjunction between religion and science is now fast becoming a crucial aspect that is valuable for both groups, whether you are extremely non-religious or extremely religious. There is a finding the overlap of your views and the way in which they are they can be resolved is of much higher importance than it ever has before, and it's always been of high importance to end this war between science and religion, because now it's going to start playing out in the wider world in a very ugly fashion if we don't.
This is true. Now, thank you for listening. Check out my Patreon. Patreon.com/AnnaCherry. You get benefits that are awesome. But also, we're 63% on the way to making this a podcast and having some super cool interviews. Emphasis on the cherry part of the CherrySTEM. We're going to be having some porn stars and others interviewed. It's going to be great. And instead of a private RSS link, it's going to be like a public one, hopefully one of these days. But you get all sorts of things. Join us. It'll be awesome. Now, thank you all again, and we'll see you soon, next month. Good night. And we'll see our patrons in the after chat.
Yes.
But everyone else, thank you for watching. Like and subscribe.
Like, subscribe, and obey.
Good night.